Okay, Christina, your question was about the greatest integer function. That's what that thing was called that you asked me about. It's discussed on page 168 of your book, and on this page they define this function for you. They say if you see an x and it has these double brackets around it, what that means is it means the greatest integer less than or equal to x. So as a couple of examples, what if you had a double bracket and inside that double bracket you had, say, 0.6? What is the greatest integer less than or equal to 0.6? Well, the integers are the counting numbers, like 0, 1, 2, 3, 4, 5, but they can also be negative. So -2, -3, -4, those are all integers. What is the largest integer that's less than or equal to 0.6? Well, if you think about it, it's 0. As another example, what is the greatest integer that's less than or equal to 3.5? So if you see a 3.5 in these double brackets, the greatest integer less than or equal to x, or sorry, less than or equal to 3.5 is 3. What is the greatest integer less than or equal to 4? Well, actually, since there's an equal in this definition, that's just 4. So what we probably should do is start to get a graph of what this function right here actually looks like. Let's see if we can start to do that. So if we wanted to use function notation, what we would say is f of 0.6, that would be replacing x with a 0.6 in the function. We already decided that the greatest integer function of 0.6 is 0. So the first point on our function is f of 0.6 equals 0. And if you wanted to graph that, I guess I can put it over here. I'll say this is 1, 2, 3, 4. And I'll make it a little smaller on this axis, 1, 2, 3, 4. We have a point on our function, 0.60. So where is that? That means the x value is 0.6 and the y value is 0, so it's somewhere around there. We also just found that we have a point, f of 3.5. If we replace x with a 3.5 in this function, we get what we have right here, the greatest integer of 3.5, it's 3. So we know that we have a function value, 3.5, at x equals 3.5, whoops. At x equals 3.5, we know that y equals 3. So we know we're going to have a point right there. And we can keep going with this, of course. We know that at f of 4, if we plug in x equals 4 into this function, we get this greatest integer function of 4. And we found out down here just by talking about it that that equals 4. Now, just plotting a few points is not really going to help us all that much. What we have to do is we have to inspect this a little bit further. You have to think to yourself, well, look at this first value that we looked at. We plugged 0.6 into it, but would anything have changed if we plugged in 0.5 or 0.7 or 0.8 or 0.4 or any number really between 0 and 1? Would our answer have changed? No, it would have always been 0 because the greatest integer less than any number between, say, we'll say roughly 0 and 1 is going to be 0. So we know that no matter what point we pick for our x value, we're going to have zeros all along this little piece of the x-axis. Now, we do have to consider a detail here. We do have to consider what is f of 0, and we also have to consider what is f of 1. F of 0 is the greatest integer greater than or equal to 0, and I think that is just 0. Now what about f of 1? the greatest integer less than or equal to 1 is going to be 1. So right here, at this point, x equals 1, the function is going to jump up to 1. The way that we draw this on the graph, to be explicit, is we draw an open circle there, down here at x equals 1, because we're saying the function does not exist here. It actually jumps up to f of 1 equals 1, to a y value of 1. Now, if we think about this a little further, what is f of 1.1? Well, that's the greatest integer less than or equal to 1.1, which is, again, just 1. So we're going to have another group of points. No matter what point we talk about in between 1 and 2, this greatest integer function is always going to give us a value of 1. So it's going to look like this, basically just like a straight line, until you get to 2. In which case you have an open circle here, and the function jumps up to a y value of 2. And this pattern repeats. You get a function that looks like this. And it goes on forever. Of course, this graph that I've drawn is just terrible, but they have a nice picture of one in the book. Now, in section 2.1 of your book, they talk about these kinds of functions. This is a piecewise function because it can be defined as several different pieces. The way that this is done is you write f of x equals, and then you divide it up into the pieces. So there's one piece that happens between x equals 0 and x equals 1. So you say, okay, there's one piece that happens between x equals 0 and x equals 1. However, this piece does exist at 0, and it does not exist because of this open circle at 1. So it looks like that. And what is the value of the function between x equals 0 and 1? Well, it's whatever this y value is right here. And this y value right there is just 0. Let's go to the next piece. The next piece exists between 1 and 2. X between 1 and 2. Again, we have an equal sign because we have a closed dot with the x equals 1 side. And on the x equals 2 side, we have an open circle, so we have a less than sign without an equal sign. Now, between x equals 1 and 2, what is the value of the function? Well, the function has a value of 1. No matter where you are here, your value of your function is 1. Now we could keep going with this. We could say, okay, let's go to the next piece. The next piece exists between x equals 2 and x equals 3. And what is the value of the function right here? Well, if you go over here, it looks like the value of the function is 2. And so on. You can do this forever. So hopefully that at least begins to answer your question about where all of this interval stuff comes from. Basically what they've done is they've defined for us this new piecewise function. It's called the greatest integer function. It's something totally brand new. And then the reason that they define it in this section is because in this section they talk about piecewise functions in general and how you can write them down in a way that looks just like this right here. So I hope that helps a little bit, and let me know if you have any questions.